In this video, we're going to talk about indicators. You're familiar with indicators. We've used them in labs before, but I just want to explain to you how they work. So indicators are compounds that have colors that are sensitive to changes in pH. And so depending on how acidic or basic the solution is that you put an indicator in, it will change colors. One that you're familiar with is phenolphthalein. And if you look at the structure on the left, you can see that it's got 3 6-membered rings, and then it's got this 5-membered ring down here. And under acidic conditions, that's the structure that it has, and it appears to be clear or colorless. And then when it becomes more basic, and you can see pH of greater than 10 or so, this 5-membered ring breaks apart. And so you've got the 3 6-membered rings, but it also forms a double bond, and that causes the color to change. So the chemical makeup of it changes, which causes the color change to the dark pink or magenta that you saw if you think about the alkaline earth metal lab. And there are lots of different indicators. You can see that different indicators are used for different pH ranges. So here's phenolphthalein down here, and it goes from colorless to pink between about 8 and 10. But you can see that there are lots of other indicators that make changes at different pH ranges. So depending on what you're looking for and what compounds you're using, you can use these indicators to tell when you have crossed a certain pH range. And that can be really important for things in industry or for telling what is happening in a given situation. If you look, there's something called universal indicator, and if you saw the Alka-Seltzer rainbow in class, it's just a mixture of different indicators. And with the Alka-Seltzer rainbow, we started off with a solution that was very basic. And so it was over here on this right end of the spectrum. So it looked very purple, so the combination of the blue and the pink. And as the Alka-Seltzer started to react and form the carbonic acid, it became more and more acidic. So you saw it go from purple to blue to green to yellow. And then at the end I added some vinegar, which is even more acidic, and it pushed it to orange or almost red. So you can see that depending on which state the indicator is in, it gives it the color, because at the beginning you have just the blue and pink, which makes it look purple, but as it moves left, it becomes more acidic, it goes to a lower pH. The pink becomes colorless, so it starts to look more green because you've got yellow here and blue here, and then it becomes more yellow because these indicators are all yellow in this area, and then it becomes more towards orange, especially after the vinegar is added. So indicators work by changing color depending on the pH of the substance that they are in. See you in class.